Hello, CIS27. In part 2 of the lecture, I want to show you how Cane Enable is used on a virtual machine that I previously used before, and it has Windows 7. And Cane can be used for various things from testing password or cracking password to sniffing out network traffic and looking at wireless passphrase. So I downloaded Cane on my Windows virtual machine here, and I would run it. So open up the application, we're going to allow it. And before we get into Cane, I want to show you that on the control panel, I wanted to look at the user accounts. So in my accounts, I'm logged on as the administrator, and I would have these other accounts that are password protected. Some have complex password and some don't. And the guest account is disabled. So what we're going to do is we're going to use Cane on the system to be able to check out the level of passwords that each of the account would have, whether we can brute force it or not. So, and as you can see here, Cane has many different features. We can use it for the network. We can sniff out network traffic. We can use it for cracking password. We can trace route. And so there are many different features for Cane, as you can see. So now we're going to use the cracker, which shows the little key. And what we're going to do is we are going to create a hash list. So here is where we're going to go ahead and click import, and we are going to select it from a text file, which is a word list, and we're going to go next. So now the NTLM and the LM is the basic for the Windows systems, but you can also work with NTLM version 2 and other type of hashes when you're trying to use this to crack different type of system password using Cane or test the password. So now what we're going to do next is we are going to select an account, and we are going to let the software crack that particular account. So again, I simply click add here, create a list. You can include the password history hashes. If you have a dictionary word list, you can also import in a word list. But we are going to just do the import hash from the local system. Click next. Then we're going to go ahead and select the account. We're going to right click and choose brute force, and we are going to use the NTLM hashes. So now then we are going to click start, and it depends on the complexity of the password. The level of complexity is going to tell us, so sometimes it would take longer if the password is complex, and sometimes it would be faster. So in this case, what we see is that it tells us this is the predefined hash, and here is the different tries that it puts in, and it puts in how many passes per second, and it tells us approximately how long that would take. Okay. Now, depending on, again, how complex the password is. So as you can see, this particular account has more of a complex password, so it might take a little longer. I'm going to go ahead and stop that. We can go ahead and do a test one account. We're going to go ahead and right click and choose brute force and use NTLM hashes. We're going to go ahead and click start. And as soon as I click start, you can see that it cracked 1. So we're going to go ahead and exit. It shows me that the password is ABC. We're going to try it for the second one, a second account called test2. And again, we are going to use the NTLM hashes. We're going to click start. And this one should take a little longer as it would have more characters. And depending on how fast the system is, but it tells you how long that would take. So compare between the test 1 and the test 2. Test 1 has ABC and that doesn't even take 1 second. And for test 2, as you can see, from having more characters, that would take a little longer to brute force for NTLM hash. And so what you can see is that the more complex the password, the longer it would take to be able to brute force this. And keep in mind that I'm using a virtual machine that uses the single processor. So realistically on a regular system, that will be much faster. Okay. So we would then have, once we wait and it's completed, we would have various passwords that were plugged in here. Okay. Now for I'm going to try test 3 so you can see. And test 3 just took a few seconds. It cracked the hash and it shows ABC12 for test 3. So test 2 took a little bit longer than test 3. So as you can see, with the 5-character password, that only took a few seconds on key. So now going back to our notes, in our notes, it talks about how we could use pass the hash. And in the notes, it says that NTLM version 2 is a little bit better, but it doesn't mean that it's uncrackable. As you can see that in Kane, we also have an option for NTLM to crack. Then for another form of attack would be the birthday attack. And based on the birthday paradox, if we're looking at the number of the people that are in the room, and if we look at 23 people, for example, and if we wanted to look at how many people would have the same day that they're born, or the same month that they're born in the year, then we would be guaranteed with 2 or more because 23 is higher than 12 months. So the attacker would create the password that produces the same hash as the user password. And what they do is they would use this as a hash collision. And hash collision occurs when hash algorithm creates the same from different passwords. And they can use that with MD5 or with SHA. So SHA 3 is with using 512 bits. This is not susceptible to the birthday attack, where the other version might be susceptible to the birthday attack. And MD5 definitely is susceptible to the birthday attack, where they can use the hash collision in order to guess your password. Rainbow table attack is when they attempt to discover the password from the hash, and Rainbow is a database of a pre-computed hash, and this could be found on the internet, could be exchanged from one attacker to the other. They can build the rainbow table. Assume that the attacker has the hash, then that hash could be used to crack the password. So the application would guess a password, and the application hashes the guest password, then it would compare the original hash with the guest hash. So if it's the same, then it will be able to find the password. A technique that we can use to prevent rainbow table attack is to use salt. And salting password is to inject random data into the stored password. And so we can simply add additional characters to the password before hashing it. So that way it elevates the security. So for the next question, it asks you about how to reduce the risk of the rainbow attack for 13. We would use complex password policy. We can use salt in our password. And we should teach the user or train the user. So we would have more user awareness and training for number 13. After rainbow attack, the notes on page 5 talks about replay attack. And replay attack is often related to session or communication, where a third party or an attacker would attempt to capture the data and impersonate either the source or the destination system. And it could be done on wired or wireless. And it would use protocols with timestamp to minimize the replay attack. So we would use protocol that logs, right, and also open a certain timestamp or have a timestamp and open a certain time window for the session, so that way they cannot replay the session for their attack. Next is the known plain text attacks, and the attacker would sample plain text or ciphertext from the captured encrypted messages, so that way they can discover the encryption and the decryption method. And ciphertext only attack, the attacker would not have the plain text information, but they would use the vulnerability in weak cryptography algorithm. In the plain text attack, they would try to decrypt the plain text from the discovered encryption method. So whatever that was already been discovered, they built a list of what the plain text equivalent could be for that encryption. And then the known plain text and chosen plain text attacks are usually successful if the attacker has time and resources on hand. Next, we're going to talk about hijacking. And hijacking can be in different forms. They can hijack a session. They can hijack a domain. So typo swatting is a form of URL hijacking, in such that anyone can buy a domain and they would choose a domain that's close to a legitimate domain to host. And so that way they can lure in people who have typo error to the domain name, and they would embed malware or get people to type in their username and password by social engineering, etc. Clickjacking is where they would trick the user to click something other than intended. So it would use HTML frame that allows web page to display within a certain frame. And this method would focus on breaking or disabling the frame. So they would add the code to cause this to happen, so in which we would need to verify and review our code to prevent the use of the frames. And that's how we would combat this form of attack. Session hijack is where we would take advantage of session ID that store cookies and they would impersonate the user with web browser, would poison the cookie by first read the cookie through website scripting or cross-site scripting, so that way they can obtain the ID of the cookie, and they would insert the ID into the header and send it to the website that's accessing the account. So in this session hijack, they actually have to perform cookie poisoning and cross-site scripting attack. For domain jacking is when they would change the registration of the domain name, and the person that's the target, the victim, will not be aware of it. They would use social engineering technique to gain unauthorized access to the domain and the victim information. So for the next question, number 14, it asks you what occurs during the session hijack. They would take advantage of the session ID stored in the cookies. They would impersonate the user with the web server. They would read the cookie through the cross-site scripting attack to obtain the session ID. And they would insert the ID into the HTTP header and send it to the website to access that user account. So by that point, they would impersonate the user account. And in following the domain hijacking, we need to talk about man in the browser. This is a type of proxy Trojan Horse that infects vulnerable web browser, and the capture browser session data such as keylogger is a Trojan. Zeus is another Trojan that includes keylogging, and it also be able to grab authentication information. So man in the browser, it would sometime embed Trojan horse or malware, so that way they can obtain the authentication information. So for 15, it asks you for the tool that is used to capture session in man in the middle or man in the browser attack. They would use Trojan horse to infect vulnerable web browser like the old Internet Explorer. They would capture browser session data using keylogger, and that would entail authentication information. But ultimately, they need to really research what type of browser you will be using, and they would trick you into giving up information with the Trojan horse. So you also see there are attacks that address driver, and driver manipulation attack includes shimming, in which it makes it appear like it's the old driver that would be compatible. So shimming provides a solution that makes it appear old driver that are compatible. We would need additional code that would run instead of the original driver. And refactoring is where code that rewrites internal processes for external behavior that changes OS. So driver manipulation sometimes would be embedded in a form of malware, and it would mainly cause disruption or corrupt the system. Zero-day attack is taking advantage of zero-day vulnerability in the application of the software. It's an existing bug or a weakness that is unknown to the trusted source, so such as OS or the application. And the exploit, zero-day exploit, would be an undocumented, it would capitalize on the vulnerability and take advantage of that vulnerability, so that way when the software is released, that bug is already been utilized at the 0 day. So to reduce this type of attack, we would need to prepare patches and fix beforehand. So that way we would fix the code, we would patch the issues to reduce the vulnerability and reduce 0 day exploit. Memory buffer vulnerabilities would cause memory leak, and this is in the development of the code where the application would consume more memory than allocated, and that would cause by reverse memory for short-term use and not releasing it. So this would need to go back to the development team to be able to fix the problem, to make sure that it would be efficient for space in the application development process. Integer overflow is where it would use or create numeric value that would be too big for the application to handle, where it makes the application would have an accurate result. And we can look at how we handle input and error to reduce the problem for integer overflow. Buffer overflow occurs when the application received more input or different input than expected. It would then expose the system memory and enable the attacker to include malicious code into the area of memory. So the attacker would send a single string of data to the application that would cause buffer overflow. Then the string along with the string of knobs, followed by malicious code stored in the victim system memory. Malicious code would then be activated. So how do we fix this problem? We would fix it with error handling routines and input validation to prevent buffer overflow. So these type of issues you would see with development. Pointer dereference is where we use pointer to access data array, and fail dereference operation cause the application to crash or corrupt memory. DLL injection is where DLL is a compiled set of code for the application used instead of the rewriting of the code. Attack would inject DLL into the system memory that cause it to run by attacking the running process. So a lot of these issues you can see would be coming back to input validation, sanitizing your code, patching your code, making sure that the client and the server side input are validated, and so that way it would increase performance and security. Race conditions and error handling. This deals with also application resources and routine handling in the development side of the application. So when we use encryption for the data, application needs to decrypt the data in order to process it. So in any case, at a certain point, the application would need to be able to look at the data, and it needs to decrypt it. So in that case, this is what you would see when you're installing app on your phone, is where you would have a certificate that would tie to that particular app, and that certificate would pertain to the authentication, how it would be accessing different resources, hardware on the system, and some certificate would include code signing and digital signature. It would also include hash, and it identifies the authors that verify the code. So in some attack, the attacker would make a falsified certificate as well and use that certificate to tell the system to trust that whatever the content in that certificate. So in development, we gotta take a look at how code is being developed, the quality of the code, how to test the code, and how the code should be unclear to the attacker that would look to replace the content of the code. And in software development, we want to test the code and qualify the code based on these tactics. We can use static code analyzers that allows us to examine the code without executing it. It is a tool that basically automate and look at the code and analyze the code. Dynamic analysis, it checks the code as it is running. It's called fuzzing. And fuzzing uses computer program to send random data to the application to cause it to crash. Stress testing simulate live environment to determine if the program is efficient. Sandboxing is used in isolation to test program, especially program that you don't want impact the rest of your network. Model verification is used to identify and remove bugs in the application. So in development, we would follow a development life cycle. And the development life cycle is based on software development life cycle, your SDLC. And sometimes that will be structured based on frameworks. So we would have waterfall model that would require top to the bottom. Each stage needs to be completed in order to proceed to the following stage. And this model encourages interaction with customer during the requirement stage, but not in the later stages. And in the waterfall model, you would see requirements to be obtained from customer at the beginning, then design, then implementation, then verify, and then maintain. Agile uses principles that share cross-functional team. So you would see stress interaction, creation of the application, collaboration with customer throughout, and responding to change. In security development operations, you would see SDLC being implemented, but with security in mind, so there would be secure automation in testing and checking code. And for continuous integration, that would need to look at where the code is stored centrally and how it would be built and tested centrally. Then with that, we would have baselines established so that way we can look at the changes in the code, and immutable systems where in the case it cannot be changed. We would also want to control change and through the different versions, so there would be version control and change management incorporated. And also in development, you would see provisioning and deprovisioning, especially relating to the user accounts that would have access to resources, and deprovision of account, they would be removed from the resources or disabled. Now, application attack can happen. It would happen on application server or web server. Web servers tend to be high susceptible to this form of attack because many applications is running via the web. So we would look at the type of web services like Apache, Internet Information Services for Microsoft, and Apache for Linux, Unix, and Windows to really making sure that we implement firewall and we look at input validation and code sanitization, and that's important. When you work with database, there's risk in cross-site scripting, and in the structured set of data, we would have multiple tables that would hold the data, and in database, you would have to organize the table in columns and rows, so that way the data can be redundant and store across the different records, be able to be accessed across different records. So here it talks about first normal form, second and third normal form. And in database, often you would see SQL being used. So for SQL database server, SQL injection can be one of the tactics for the attacker to obtain records, information from the database. And queries would be passed into the database through the web server to trick the database to give the attacker the information such as username, password, account number, etc. So we need to look at how we would protect the input and restrict the input. So input validation is very important. This allows us to protect against injection in web forms. And injection can be in the format of OS commands, where we would call that command injection. And that can be. So for question 16, it asks you what techniques are used to prevent buffer overflow. We can say error handling routines and input validations that will be used to prevent buffer overflows. And in question 17, it asks you what are the two common SDLC models and what are the differences. So we can say agile and waterfall. And waterfall would include multiple stages from top to bottom, and each stage needs to feed into the next. So you have to complete one stage before you can proceed to the next. It would require interaction from the customer at the beginning during the first stage, which is requirement, but not in the later stage. And the stages are requirement, design, implementation, verification, and maintenance. Agile is where there will be cross-functional team being implemented, and customer has a clear idea in the requirement and changes that can be made during each of the cycle. The stage would include stress interaction, creating work application, collaborating with customer, and responding to changes. So in 17 and 16, you can also refer to the notes, and in the notes, you would see the waterfall model and the agile is on page 9, and also the previous question is on page 9 going into page 10. So now on page 9, I'm sorry, for the waterfall and the agile is on page 7 to page 8. And in the last part of the lecture, it touches on cross-site scripting, and sometimes referred to as XSS. This is where the attacker would take advantage of the web application vulnerability that could be prevented. We can control that by input validation. The attacker would capture the user information such as cookies. So they would use script to gather information and poison the cookie in order to get the user information. Cross-site request forgery XSRF is where the attacker tricked the user into performing the action on the website. So to fix that, we should educate our user about the risks. And in security, we would refer to frameworks and guidelines. And frameworks allow us to follow a structured foundation in the security implementation. So you can look at NIST or NIST framework, or sometime framework would be aligned with the compliant or the regulations requirement. And non-regulatory best practices you would often see with COVID, and or if you would see worldwide, they would use ISO, and nationally they would use NIST. So these are the organizations that put together frameworks for IT and security, and you can look at specific framework that might align with various compliant entity like HIPAA for health, PCI-DSS for consumer credit card accepting organizations with financial information being exchanged. So finance industry, that would be PCI-DSS, health industry, that would be HIPAA, and so on. So we would use the framework as a structured guideline on how we would implement security measures for different area and different industry. And this concludes my video for part 2 of the lecture. Please let me know if you have any questions. Please watch the next video that will be the lab video. Thank you very much for watching.